Okay, today we are going to make life, the game of life, and we have it somewhat optimized so it only updates the right cells. You can click and it can grow, and it will grow following the rules of life, how this game works. There's really only 4 rules, kind of 5 if you consider dead blocks stay dead if there's nothing around them. So it's going to be fairly simple to program, but I thought it was an interesting project on how to kind of work with grids and how to get something to be somewhat optimized. It's still not great optimized. If you get a big enough thing to around 200 blocks, it'll start to lag in Blueprint, but I'm sure if you made it in C++, you could get it going faster. And then we're also going to, at the end, make some pause controls where we can change the speed, or we can reset things completely to go again like this. Yeah, that's what we're going to be making. We're going to make it from scratch. It's fairly complicated. We're going to start with the fun stuff first to get it working, to get something that you can actually see as quickly as possible. But then from there, we are going to then add in the more complicated features, and lastly we'll add in the UI at the very end. So let's get started. We're going to make this in Unreal 4.27, and that just because it's easier to migrate forward than it is backwards, so you're welcome to do this in a later version of Unreal, but we're going to be doing it in this one just so for the compatibility reasons. Okay, so what we're going to start with, we're actually going to start with the puzzle game. We're really not going to use a lot of it. I'm just going to call this Unreal Life Tutorial, just like that. And we're just going to create this project. The main thing we want is in the puzzle game, the controller. The controller has the mouse cursor and click events all turned on by default, which we could do, but alright, so let's just gut this scene. We don't need light mass. We don't even need a light source. There's only really a few things we need. We don't need a camera, we don't need a cube, don't need any of that. I'm going to throw in some height fog just to have a background color. It's probably an easier way to do this, but height fog works pretty well. And I think I set my height fog just at 0.1 as a value, like that, to give it a gray. And then we're going to work on the player character right here. All of this we can cut out. We don't need any of that. We don't need the VR camera. Yeah. And then this actual camera, we're going to change its settings a little bit. Since we want it to be isometric, I don't like how orthographic, but I don't actually like how orthographic renders things. So a way to get something similar is you just put it really high up. So I'm going to put it at like 40,000. And then you make the field of view really narrow. That's not perfect orthographicness, but it will at least render correctly, and then make sure it's tilting the right direction, so minus 90. So if we go into viewport, and there it is, looking down, perfect. Okay. On begin play, we're going to want to create something. We're going to be doing 2 things. The first thing we're going to do here is we are going to This is, here, let me just label these two things. This will spawn in the grid. And then down here, we're going to set up the UI. Like that. And then I'm also going to, I just like to do this. You don't need this in editor since it works in editor by default. If you make a build, it's nice to be able to exit your game without using Alt F4. Okay, so we need something to actually fill in this grid. So right now it plays, it's just gray. So we are next going to make our life grid. So custom art, oops. And then we'll call this life. And we're just gonna make a blueprint. It's just gonna be an actor. And this will be, we're just gonna call it life grid. So let's open this up. And the first thing we want to do here, we're going to make this on begin play. Oh. Something's wrong. Just a second. There we go. Hold down S to get a sequence. And once again, we're going to be doing two things here. Down here is set the starting cells. But the first thing we're going to do here is create the grid. That will be right here. Which, in order to do that, we're going to need the cell. So we'll just call this life cell. So, in order to create a grid, let's call this life cells. This is going to be an array, and we can just look up that blueprint we just created, life cell. So to start, we're just going to clear this array. And then we're going to need some for loops. We're going to need two of them. Not for each, but actual for loops, just like that. And these will be back to back because we have a 2D grid. Obviously, if this was a 3D grid, we would have two of these. And we're going to need some variables. So the first variable is going to be grid size. And this is going to be a 2D vector. We want that just to be a normal thing, and we're going to make that exposable, and we're also going to make it expose on spawn. And then the other, we might as well create the other variables. We're going to need an update delay. Which will be both of those, and this will be a float. And then we're going to need cell size, like this. Okay, and I'm going to drag that down. Okay, so let's go ahead and put some default values in these. So in terms of grid size, I'm going to put this 9 by 6, and we'll see. Actually, one second. Let's not do that. Let's do 16 by 32. Okay. And I hold down Control to drag it in here, and we're going to split this so we have both vectors. We'll need to subtract 1. And then we can just hook that into there, which will create a truncate. Okay. So, and this gets plugged into the last index. And then for y, we're going to do the exact same thing, but it gets plugged into the second for loop. So this will kind of spawn, loop through each axis and create the cells one by one, which is what we need. We'll do spawn actor, which we can grab the life cell right there. Let's go ahead and add some variables to the life cell. The ones we need is we're going to need the parent grid reference, which we'll need to also, and this will be life grid, like that. And we'll do some other stuff in here later, but that's the one we need for now. So let's refresh this. Did we save it? No, there we go. If we refresh this, there we go. Parent grid, which will just be a reference to itself since this is the parent grid. And then this array we made, we are going to do add unique. Okay, there we go. However, we need to set up the transform here. So I'm going to split this. I'm going to do the scale real quick since scale is quite simple. We're just going to take the cell size, which the thing we're going to use here, I'll throw in the static mesh, and we're going to make that the root, and we're just going to use the chamfered cube like that. We're going to replace this material, but that's what we're starting with. And if you looked, it's 100 by 100. So we're going to divide this by 110 or 111, and then we're going to put that into the transform. Here, let's make a vector so it's a bit more clear what's happening here. So that way they're all scaled with a little bit of a gap in between them, so we can see that actual grid pattern. In terms of the transform, I'm going to walk through the math in order to get the transform right, but the thing we know for sure is we will want this to be local. So we will transform location, just like this, and we'll just get the actor transform like that. And then whatever that means, if we move this thing around, it will move with wherever this actor spawns. So it's a bit more consistent instead of being world space. We probably could keep it world space in this instance, since we're just going to be spawning it from the player, but okay. So now we have cell size. Let's get the actual transform for each of the cubes. So we start by multiplying this by this because this is how big each cell is. So that's about the distance we want to move it. Like that. And then we are going to use the cell size here. We can split this again. And dividing this float by float. This gets divided by 2 for each of these, since I kind of want it to spawn from the center. So I'm going to move basically the entire grid over by half of the grid, so that way the grid gets spawned from the center. I'll show what this is doing as soon as we hook it up. let's make a vector which we only care about x and y. Top one is going to be x, and then the bottom one is going to be the same, but it'll be for y, of course. Okay, so this should spawn in our grid. So let's see, let's actually do this within the player. I'm going to spawn actor, grab the grid, and just put that in there. You see we have our values. Let's go ahead and add some defaults. So let's say the cell size will be 40, and might as well add a default here. Update delay will be 0.3, so it doesn't lag if we forget about it. I'm also going to move this slightly, just like up a little bit. So I'm going to make vector, and I'm just going to move it 100 up. I feel like it sits a bit better on the screen. So for example, you notice for ours, it's a bit more towards the top than it is bottom, just to make room down here. It's not a lot, but that's partly, we're going to do that. And we're going to grab a reference to this. So life grid ref. Okay, let's see what this does, or if this even works. Okay, I think our camera's facing the wrong direction. Let's figure out why it's doing that. Do we have, where's our spawn point? Oh, we don't have a spawn point. That would make sense. Let's add in a spawn point. Player start, and let's just drag this down here. Okay. Still, one second. Okay, camera's rotated 90, it's facing down. Is this getting spawned in? We got, let's do always spawn, ignore collisions. Oh, none of these are updated. I see. There we go. And then we want something in the actual grid size as well. 16 by 32. Let's see. Okay. So that is spawning. I think, there we go. I think that's what it is. Or no, that's set correctly. Let's see if we can get a sense of what's actually happening. Okay. So the grid is spawning in. Player controller, player start. All the cells are there. Puzzle, player character, camera. Oh, did we use the wrong? Oh, I know exactly why. Since this is not, has been set to auto activate. There we go. Okay, cool. The grid's a bit weird, but this is working correctly. 1 second. We just need to auto activate that camera. So let's go ahead and get these settings correct. Let's switch these. Now 16 by 32, that's correct. Always spawn. Rotation. Is the camera rotated strange? Let's look here. If we double the size. I think I might be feeding these in wrong. -1. X and Y. Transform location. Spawn transform. If we reverse these, what does this look like? It's getting spawned in a very strange way. All right, let's check the cells. They're good. Okay, let's check. It's eject here. Camera. Oh, right. I don't think we're properly moving the grid over. So this here, cell size. I think maybe we have yeah, we have these reversed. Or really, these should be reversed like this. This should go there. This should go there. Like that. Excellent. Okay, that's what we want. And then we can switch these back. There. Wonderful grid. So it's moved into the center. So that way it's lined up with the camera, and you notice it's moved a bit up. Okay. Excellent. Okay. So we've now spawned in the grid. We can't do anything with it though. So what we're going to do now is we're going to make it so you can click on a cell. So the next thing we're going to make is we're going to make a very simple material. I'm just going to call this m_life. And we are going to hold down S and make a scalar, and we're just going to call this alive ? And this will plug into the base and the emissive, and then I'm going to put 0.2 in the specular just to make it a bit less shiny, and I'm put 1 in the roughness to make it rough. And we will save this, and we are going to dump this onto the life cell, just like that. And then the life cell actually doesn't have too many variables. We will be doing something in the construction script where we'll call this block mesh. And we are going to drag that down here and create dynamic material instance like this. And we can put that material in there, and we're going to make a reference to this. We're going to call this mat ref. Now that we have that made, I'm just going to create all the events in here. We're going to have 3 different events. One is going to be set to update. One is going to be called update custom event, update cell. Let's go ahead and capitalize that. And we're going to have a few variables. We're going to have one that is just alive, question mark. All these are going to be booleans. Then we are going to have another variable, which is going to be update, question mark. And then the last variable is going to be state to update to. And for the first one, set to update, we're going to plug that in, and this is going to be, we're just going to label this alive. And then we are going to flag it to be updated like that. In terms of the update cell, we're going to have a branch here, which you can hold down B to make a branch. And then you're going to do state to update to, and alt alive. And then this is where we can set the scalar. If we grab this here, set, there we go, scalar parameter. And if you remember what this was called, it was just called alive, which is what we named it here. And then this is a float, but booleans when converted to floats is just 0 or 1, which works for us since that's what we want to feed into the keller is 0 or 1. So we can literally just drag this right into there, and that works. And then after that does, we can flag it to it no longer needs to be updated. And then the last event is going to be on clicked right there. And then we are going to grab the parent grid, and we are going to do not, since we wanted to do reverse of whatever it currently is, and we need to create an event now in our parent grid, which we are going to do on user clicked. So this is going to be a custom event, and it's going to be user clicked cube. I guess we could call it user clicked cell, like that. And we're going to need a few different things. So in the input, one is just going to be the cell. So then cell, life cell, just like that. And then a boolean, just alive. Boolean, like that. And then we need a function here, which is just set cell. Which we need some inputs here. Once again, it's going to be the same inputs as the other one. So this will be cell and alive. And this one will be cell, live cell. And since we already created these events here, we should be able to reference them, assuming we compile this correctly. So we can set it to update, whatever this value is. And we're going to drag this down. And then we're going to update it. Just like that. And I guess we can plug this in. Not sure it matters, but there we go. So this is our set cell, which we can call here. Just drag in this function, and we'll set it to whatever that will be. And then this should actually work, so it doesn't. 1 second. Oh, that's right. We need to user click cell alive, and then this will just be self. Get reference to self like that. There we go. See, and we can click things. Nothing's updating, but we can turn cells on and off. Half an hour in, and we have a grid that we can click and things turn on and off. Excellent. Okay. And then we're going to create a few more. We're going to finish this function here, actually. And we're going to do things that will be relevant to later steps. And in the process of this, we're going to actually make some functions that will make things quicker later. So the next thing we need to do is we're going to find which cell we just turned on and off. And we are going to create a function, which is called, it's kind of a, it's going to be like kind of the heart of our system, but we're going to make it as a function. And it's going to be called get neighbor indexes, like this. I think even though it took half an hour to get this grid, I think we'll be able to finish everything else in half an hour. A bit more than that. So this will probably be like maybe an hour, 10-minute video. We'll see if I'm right. To make this function though, get neighbor indexes, we're going to want an enum. Control Shift S, by the way, guys, to save everything. So if we go under blueprints, enumerator, this will be E neighbors. Did I spell that right? No, I did not. Neighbors. And this is just going to be a series of 8 different, so up to 7, so we start at 0. And all this will be is just every neighbor within a grid, which if you count them, there's 8. So 1, 2, 3, 4, 5, 6, 7, 8. And we want to kind of lay out all of those. I'm going to label them by the XY axis. So this will be like plus X, this is plus Y, since if you notice on the grid, green is Y, yellow or red is X, so up is X, so this is just plus X, this is plus X plus Y, this is just plus Y, this is minus X plus Y, and we're going to do that for every single direction. It doesn't really matter which one you start with. I'm just going to start with plus I'm going to start with the top right, which is going to be plus x plus y. And then I'm just going to go clockwise around. So plus y minus x plus y minus x minus x minus y plus, or I'm sorry, minus y, and then plus x minus y, and the last one, very top, plus x. Okay, so then this enumerator, we are going to drag in here. It's actually going to, we're actually going to create a few other variables that will be used in this. So I'm going to start naming these. I'm going to do startup, since this will get used in our startup. And this one I'm going to label under, I'm just going to call it utilities, like this. This will be a pure function. So what that means, if you drag in a pure function, well, it doesn't have any variables. It depends if it has that these little arrows on them, if you can execute through it. We don't need those arrows, so we'll just make a pure function. We can actually close that one, and we'll delete that for now. Okay, so get neighbor index is going to be another function we're going to make. We're going to throw this into utilities as well. And get neighbor index is where we're going to actually use this variable. So in the input here, we're going to do neighbor direction, and we're going to grab that enum. So if you recall, we called it eneighbors right there. And then what we can do with this, I'm going to create two more variables. I'm going to input index, and this is going to be neighbor index. These will both be integers, like that. And the nice thing about an enum is we can create, if we click select, it gives us an option for every variable, which are going to be integers. So we need to do a bit of math. We're going to want the grid size, and we're going to want the y. I'm just going to truncate this. Okay. So what we're kind of doing is we're doing some math. Let me actually explain this. I'm going to let me click something first. There we go. So if we have this grid, let's say this is tile number 12, then we know if we want to go to the right, this will be 13. This will be 11, since the grid is assembled from the bottom left corner and it gets built, right? Which means if we want to go one down, it's going to be whatever the value of y is, which is however long our grid is, subtracted by the current value. So if this is 12 and our grid is 5 across, then we know this one must be 5 less than 12, since it's a row down. So obviously, maybe we can use some actual math. So here's what I'm going to do. I'm going to do a call event whenever we actually click something. So we're going to find this, and we're just going to print this out. Print string, and we want to find where is this, which integer is this within the grid. So see, 300. I don't want to do 300. Let's do something that's closer, like this one, 37. So 1, 2, 3, 4, 5, 6. So this will be 5. So yeah, that's cell 5. So if we do some math, 37 minus 5 is 32. And if you look, conveniently, that's how big we made the grid. So if we just subtract y by the current value, it will get us the one below. And inversely, so if we know our original cell was 37, if we add 32, we can guess that 69 will be the cell right above it. So let's go back to our map. We're in window here. So this will be 69 would be our guess. Look at that. Very nice. So using that, we can mathematically determine what we need to do with the index to get every single direction. So I'm going to kind of paste in that math, but this is going to be the heart of checking the neighbors. And if we can do this, then anytime we have an index, we can immediately get any index around that cell, whether it be diagonally, up or down, it all works. Okay. So basically all of these are just going to be plus. All the diagonal ones, we're going to be adding 3 different integers, and all the single ones, you'll just be adding one thing. So we can copy this 3 times, and we're just going to plug all of these in. Obviously, we're not adding the right values yet, but this will get us started. Okay, here we go. To help us out as well, some of these we're going to be adding, and then some of them we're going to be subtracting. Instead of having to use different nodes, I'm just going to multiply this by -1. So we have a negative value, so it's easier for us. So for the ones that we want to move just like y, so where is it? -y. We will literally just take the index. So that this index will plug into all of these, because this is our starting index. We're actually going to do it in like 2 pairs just so it's a little bit these lines will get very messy very quickly. Let's do it like this, just so it's a little more condensed. Okay, so the starting index, we're going to be adding something to every starting index. So this obviously needs to get plugged into all of them. So for the ones that are, some of them we can figure out pretty easily. So it's like if we need to move it 1, we're just going to add 1. So that one's actually correct. If we need to move it 1 plus y, that means we will move it, but plus this as well. Right, whatever y value is. I'll try to have these visible so you can just copy where the lines are going if you get confused. So plus y minus y, so that's going to be the same, except instead of adding, we're going to be subtracting. So we're going to be adding the minus y value. And then this one here, minus y, that one, we just add this. So everything with minus y, we can do this. So how many of these, or minus x, I apologize. Minus x. So this one has minus x, this one has minus x, and this one has minus x. So we can do, okay, that one we already did. That one, so this is the other one with minus x. Right here. And then all the ones with minus y, we just make this a minus 1, minus 1, minus 1. And then this one, since it has plus x, and then the first one also had, first one had plus x, and the second one had plus x. So this one had plus x, like that. So this will give us all the neighbors, or any neighbor we want, right? Since the way this function works is, so we're just going to grab it in here so we can see it, get neighbor index. It lets us select whatever neighbor index we want. We're going to make a little the other thing here, tell you what. The other thing we're going to make is we want to know here, just to show this works, is we're going to set whatever cell is above this. So get neighbor index. So if we grab the index here, and let's say we want to set the cell that's above every cell as well to be alive, which means we can get, and we are going to set that there. This is how to know if you did your math correctly. And we can set the cell like that. So when we click a cell, it should set that cell, and it should give us the number, and then it should set whatever cell is above that cell. So let's see if that works, which it does. So it sets the 1, it's setting whatever cell is above. And let's do just random, this will be the top right corner, which it does. And we'll do one more, like minus y maybe, which will be just to the left, which it does. Okay, so this is working correctly. We can leave that there for now. We want another system. So we get the get neighbor index, and we want another function here actually, which we're going to call it neighbor past grid edge, question mark. And this is going to be a pure function as well. And sometimes the game of life, they don't actually have a grid edge. We do. So we need to know if, see, if I click here, it jumps all the way to the edge, which I guess you could do. Like, that's a valid way to make this game if you want it to jump, but you get some kind of strange behaviors. Since it doesn't do it on top quite right. In fact, here, I'll show you. This will even, I think it will result in, so if we like go up, so there's our up, I think it actually, it returns value because there's no value. It's adding 1 to the grid, but the index is too large. We don't actually have a cell that represents that. So that's why we need to know if there's where the edge is. Luckily, that's not too hard. So, in order to, let me just pull up my reference here. We're going to be using the same kind of thing that we did here. So we can literally copy these. I guess we could have copied the neighbors, there we go. We could have copied the function, but that's okay. And then this will be input index, which is once again an integer. And then the output is going to be a Boolean, which we can call past an edge question mark. And all this function will return is like, hey, would the neighbor be past an edge? And it will just return true or false. So we can do a select node once again, but we don't actually use integers here. We want a Boolean, right? And the math that works this, we'll actually need the grid size again. Split this. Let's just do minus. It's going to be integer. Where's integer? Int minus int. Let's truncate. Okay. So the way to know okay, does this index divide by this index here? One second. I'm going to kind of lay these out and then I'll explain them. And then we're going to need a modulo, which is just the percentage. Okay. And we're going to kind of label this as well. And then, okay. So what we're doing here is x chord 0 to minus 1 max. So this, we are checking the coordinate and like, does this divide? And in the same way, I'm trying to think of a good way to explain this, since you have to kind of visualize it to know what's going on here. Because in the same way we could tell the neighbors, we can do similar math to tell if something is at the top. So it's like that's 497. Let's see, let's do the 512. So let's see what if we do 16 by 32 multiplied by 32. See, this is 512. The reason the one we printed out is 511 is because we start at 0. So we know if it's more than that, we're past the top, right? So if we take the index and hold on. If we take the index and we divide it by the size, this should give us the x size, 1 less than the x size. So this should equal, one second, this should equal if -1 of the x, which in this case is 16, so that's going to be 15. So 15 take our index, so our index would be 511. So 511 divided by y, which is 32. 511 divided by y, which is 32. So this is going to get rounded. So this should equal 1 minus x, which is going to be 15, which it will get rounded down since it's an integer, since we don't have a float. We don't have tangent. So if we know that this should equal 15 if we're at the top. So if this equals the things, we know we are at the top. Which, what that means is any neighbors that have plus x aren't going to be valid, since we know we're at the top of the grid. So we really are only going to have 4 different checks here. And then we're going to mix and match because we only have 4 different values in 8 different combinations. So in the same way we kind of had the 3 and the 2, we are going to do that, but we are going to, for every one of these that has 2 values, we're going to use an OR, since there's going to be 2 things that disqualify it. It's like either if you're at the far right edge or at the top, that will not be valid. Missed one in the middle there. Okay. So then we want to know, is it at the bottom? And this one's even easier, since we don't even need to do math. We'd just be, hey, is it 0? Like, hey, this divided by this, will it equal 0? And if it does, we know we're at the bottom row. The other 2, is going to be, this is going to be the y coordinate. 0 to minus 2, 2, minus 1, max. And this will equal this one here, which will be far right. The far right. Just for, and anyone who doesn't know what modulo does, that just gives the remainder. So we know, hey, does the remainder equal 1 less than the y value? If it does, we know we're at the very far right of the grid. And then in the same way, the one on the left is even easier, since it'll just be 0 on the far left. Question mark. Okay. And then we just hook these into this appropriately. So this one will go here, since this will hook up to everything that has a plus y or plus x. We can even, could even specify that plus x This will hook up to everything with a minus x. This will hook up everything with a plus y. This will hook up with everything with a minus y. So this one has a plus x plus y, so plus x plus y. This one has a plus y. This one has a minus x plus y. This one has a minus x minus y. This one has a minus y plus x plus y, or minus y. Yep, minus y, and then plus x. Super confusing, but if you just follow the math, it does work. We can even verify to make sure it works. Let's actually label these as well. Not quite as clean. I guess we can label, these are all the starting indexes. Let's do this. We're gonna make literal int. We're just gonna make this 1. And then we're gonna do the same with this, but with minus 1. And then we'll label it in the same way, since this will be all minus y. Minus y, like that. This will be all plus y. And then the same here. This is minus x, and this is all plus x. And you're just hooking them up like that, relative to what it says here. Okay, so we got that function, got that function. And then we're actually going to make a combined function using both of these, which is just going to be kind of it's a utility once again, and we're just going to call it valid neighbor index. So it's just going to be like this, and we're just going to use these two functions. This is going to be a pure function as well. So we're going to get the neighbor index, and we're going to ask, is it on the edge? These we can just do that to create this. Which we can do this. We want this index to be hooking up to both of these. And then we're just going to return a not. Just remember, if this is past the edge, we want it to return if it's valid. And we're just going to call this valid. And then we are going to, if it is valid, we'll return whatever the index is. Well, we're going to return the index always. But what this means is we can use it to hook it up to like a branch or something, which is what we'll do here. Okay, we've made all those functions. We're well over an hour, but we're gonna keep chugging through. This is just gonna be long. I mean, we're creating life, so of course it's gonna take a while. So here's the get neighbor indexes. This is our first, I'm just gonna grab one of these. We'll do input index, and then, oops, there we go. the output is actually also going to be an index, but it's going to be an array. So this will be called cell we're just going to turn all the neighbor indexes like that. And this is going to be an array. Okay, we're going to have a sequence here, since we're going to do something, and then that's when we're going to return. And we're actually going to make this a local variable, and we're just going to call it valid neighbors, like that. I like to label my local variables with a little L as well, like that, so we don't accidentally reference them or like pull them up. Or we'll call it valid indexes here. There we go. Okay, this is where it get kind of messy. So within this, we need to do one for every side, since we want to check every neighbor. Luckily, we have a nice function for this. So we're just going to create kind of the entire sequence here, and then we're just going to duplicate it and then change this value for every one of them. So let's go and grab in the index, clean this up a little bit. And then if this is true, then all we want to do is just add unique. And we do want to add unique because there's a chance some of the neighbors will be the same. So there's no need, we only need one reference to each of them. So this is the thing, and then we just do it 7 more times for every single direction. Do it 3 more times. I'm just going to kind of line these up. You can just shift in any direction. Okay, and then we got 4, which means we can duplicate this to be done, just like that. Remember, these all need to be set. So let's make sure not to forget that. But we're going to plug in the index into every one. So this will return a list of every neighbor. And then this needs to be hooked in. Bit tedious, but not too bad. This is actually a lot easier with those functions, with these functions. I've done this without these functions before, and it becomes a mess pretty quickly. Okay. Just setting all of these. Okay, just make sure they're all different. And they are. Okay, so this should return every single neighbor of what we're doing. So now that we've gone through all that rigmarole, we can use this. I'm going to delete this and this. And if we pull it in here, get neighbor indexes, it's this itty bitty little function. And all it returns is an array. Everything we did here, everything we did here, 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 and here, all of this, it's just this. Which is kind of cool since we're actually going to be using it in a lot of places. There's one more. I actually want not only the neighbor index, I'm going to create, this is a much simpler one. You can call it add unique index. This is going to be a pure function as well. And this is going to be a lot simpler. I'm just going to create a local variable here, call it index. I'll label it L. This is going to be a float. Alt drag, and we're just going to hook this up here. And we are just going to, we'll call this input index. Index, there we go. Actually, input indexes, since this is going to be a float, or not a float, an array, then we can, this will be added index. So this one's not, and then we want this to be an array as well, like that. So we just add this, and then we just add unique, like this. And then we just want to return this output indexes, which will also be an array. Seems like a kind of weird thing to make a function for something this simple, but we're actually going to be using it in a few different places. So in this context, we just want to add the normal index with the second one, and that way we can output this index. And I don't want to create another like master variable to do this, so that's part of why it's like that. Okay. One second. Okay. And then we can do an each loop. We want to do something for each of those indexes. And we're going to need some more variables. So we got life cells, we're going to need indexes to check. And then we're just going to duplicate this, and we're going to indexes to update, which we're going to use slightly different. And I'll do my best to explain what the difference will actually be. And we're just going to add make sure to add the array element and not the array index. I know it's confusing since we have an array of integers, and an array is counted with an integer. So we always want the array element in this context. We're almost never going to want the array index, except when we were making the grid. Okay, so we're doing that. So we've created the grid, and we have updated. Now we need to update life. Let's actually, we're going to set the starting cells since we actually have most of the functions we need to do that. So this will not, we're going to do for each. We're going to get, we got startup, utilities. We're going to add another function in the startup, and we're going to call this find center cell, or find center index more accurately. This is going to be a pure function. And this one isn't too bad. Okay. Sorry. Okay. And it is just going to return an index. Center index, and this is just going to be a obviously not all grids have a perfect center, but this will get close. If it's even, it will just round. I think it rounds down. So because of that, we will need to do everything with integers. Otherwise, your results will whenever it's even, it will get pushed all the way to one side, which we don't want. Remember, because the index start at 0, we have to subtract 1 from both of these. And then we want to just divide them by 2, since we want the center. And then in the case of the x, we're going to multiply this by however many columns there are on the y. And then we are just going to add these two. And that will give us the center cell. Just like that. 2, 2, 1. Okay. Okay, this is wanting an array. So we're going to, now we can use the center index. We can add unique index, and we want to get all the neighbor indexes as well. So remember, we use this in multiple places. This is another place we use it. And we just return this array into here. And it's nice to be able to do this without needing like a global variable every time we want to do it. And then for each of these, we just want to get, we can just get a copy. That's okay. And then we have this set cell function, remember? Which all of these we're wanting to set to be alive. And then we can use this because we want to grab the array for all of these cells, or not the array, the neighbors for all of these cells, and flag them to be checked if they need to update, which we'll do as we update things, which is what we'll actually do here. I'm going to create a custom function, and we're just going to call this start cell update, and we're just going to call it here. So let's look at what we've done here. All we've done is we've picked the center cell, we've set them all to be alive, plus its neighbors. So this should form like a 9x9 or a 3x3 grid in the center, which it does. But nothing's updating, which is what we're going to do now. So we're going to set timer by event. This is where we need the update delay. Make sure it's set to something, 0.3. Otherwise you'll probably lag your machine. This is just going to be the update timer, which we'll need to, in order to turn it off when we want it to. I'm just going to put that there. We do want this to loop, and then we are going to create a new function or event and call it update life. And then we're going to grab the cells to check, which remember we just added some things to. And then we're just going to do a for each function right there. This is where most of our updates are going to happen for life. And there's really only, let's see. Okay, so now we're going to get into basically one of the last functions we need to write. And it's actually one of the simpler ones. We're going to do cell life validation. And we're going to call this cell validation in the validation. And this is where we're going to create the rules to life. So I'm going to grab this. We actually want this to be an integer array, and we will call it neighbor indexes. Is that right? Yes. Indexes. So we're going to feed in the neighbor indexes, and we're going to do two things here. We're going to do this array, but we're actually going to do something right after it. And we're going to do a branch right after it. And then this one is going to be a cell index, which is going to be an integer, but it will not be an array. And we'll just do a get, which will grab the cells. Get a copy right there. And then we will, since we have the cell, we're just going to ask, is this alive? Okay. And then okay. I just want to kind of set this up real quick, but I'm actually going to show where we're deriving these from, since this is where we implement the rules of life. And Conway's game of life has 4 different rules, or in our sake, kind of 5. And I'm literally just going to pull up the Wikipedia article here. So here we go. So if you look, this is just the Wikipedia article on Conway's game of life. There's 4 different rules. Any cell with fewer than 2 live neighbors dies, as if by underpopulation. Any cell with 2 or 3 live neighbors next to lives on to the next generation if it has 2 or 3. And if it has more than 3, it dies. And any cell with exactly 3 neighbors becomes alive. And then the last one rule that is kind of implied here is any cell with nothing around it stays dead. Right. Okay. So first one is we're going to get the neighbors, and we are going to also ask, oh, we made that mistake. Plug it into there, not there. We're going to ask all of these, is it alive? And we are going to make a local variable here. And we are going to call this local variable alive neighbors. And this is just going to be a standard integer. And all this is doing, it's going through all the neighbors, and then if they're alive, we'll create a branch here. We're just going to add 1 to the alive neighbors. So we can use something called increment. That's just ++, like that. So now that we know like how many neighbors are alive, then we can check for the different rules. So in our return function, we're going to have 2 different returns. One is going to be the question, should we update this? Like, has anything changed? And then the other question will be, should it live? Which is also going to be a Boolean. And since we have 5 different outcomes, we are going to just duplicate this 4 different times. So we have 5 nodes here. And we're going to actually label all of these. And then we're going to hook them up. So fewer than fewer than 2 live neighbors equals die. This one, we are just going to update it, and this should not be alive. The next one is 2 or 3 live neighbors, and we'll just continue. So this one, hold on. Hold on. I think I may have messed up my reference. Okay, my reference was programmed correctly but labeled wrong. So this one is actually there. And then this one is actually there. Like that. So more than 3 neighbors die, which should be this one, update to be dead. This one, 3 or more neighbors, we want it to be alive, but we also don't need to update it since nothing has changed. And then the last 2 will be exactly 3 live neighbors, which we want to, if that's true, we want to create a node which you need to update it and set it to be alive. And then the last one, which is just kind of an implied rule, which is stay dead, which is don't update and it shouldn't be alive. And then we will really only need 3 more branches to get to these. So we're going to set this one up first. Okay, I'm just pressing Q, by the way, to make that. Second branch branches off of this one, which is these 2. And then the last 2 branches off of this, false. And then the variables we want to, the first branch is, hey, is the cell alive already? If it is, let's check this. If it's not, check this. And if it's alive, first we want to check, like, hey, does it have less than 2 neighbors? Because if it does, we should kill it. Okay, and it's like, okay, it doesn't have less than 2 neighbors. So then the next thing to check is, well, does it have more than 3 neighbors? Because if it does once again there, we should also kill it. And if not, then if it doesn't have less than 3 neighbors and it doesn't have more than 3 neighbors, then we can keep it alive. And then for the dead cells, really the only thing we need to check is, hey, does it have exactly 3 neighbors? Alive neighbors. Because if it does have exactly 3 live neighbors, we want to create it and set it to be alive. And if it doesn't, well, we'll just leave it alone. So there we go. This is the rules of life. The actual rules, quite simple. Finding the neighbors, setting up the grid, way more complicated than the other parts here. I'm just going to go through these as I close them, just so you can get an overview. In case you want that. Okay, the rules of life. So now that we have that, then we can pull this guy in here. We can use the get neighbor indexes like this. So we can get the array element, or not the array element, the array element, not the array index. And then we can loop this around since we want the cell index as well. And then we can check, hey, should this update? If we do want to update it, go ahead and grab the cell at whatever index this is. And then remember we created a function here, set to update. So we'll just call that set to update. And we'll update it to whatever it should be. Should it be alive or not? And then we are going to grab this indexes to update, and we're going to add unique here, and we're going to put this in the index to update. Okay, and then now that we have this index to update on completed, we are going to go ahead and clear this one. We're going to clear out the cells to check since we've used this node. We will reuse that in the next cycle, but we want to clear it out for now. And then we are going to do indexes to update, and we're just going to grab a for loop right here. And then when this is done, then we'll clear this like this. A way to check if this is working as well is we can then also get the length of this. Hold on. Okay, we're gonna finish this. I'm getting distracted. Okay, array element. I'm kind of rushing through this because as soon as we finish this, then it works. If it doesn't work for you, just let me know, and I can probably help you debug if that's something you want help with. Get neighbor indexes, and then we are going to go ahead and use that add unique index. Like this. And then we're going to do each. And then we are going to update the cell like this. And then we're going to take all the neighbors of the cell that just got updated, and we are going to put them in indexes to check like this. And the way to tell if our optimization is working is we can actually print string. I'm going to pen this real quick, and we're going to print out the length of this. We're going to make this last as long as the update lasts. And then we're just going to paste in here, or right in here, cells updating. So we can know how many cells are actually updating. Is it updating the entire grid at once? If it is, we know we're doing something wrong. Or is it only updating the cells around the stuff that is active, which is what we want. Okay, so this should work. Let's see. Kind of did a lot without checking. There we go. So there's life. And you notice if we click something, we can get stuff to happen. And you notice it's updating, but it's not updating the entire grid. It's only updating whatever's relevant. So you notice also when nothing is active, it updates 0. So it only updates as stuff moves around. But when stuff isn't moving around, it doesn't update anymore, which is super cool. On my machine, at least, it starts to lag around 200 cells updating at once, but I'm sure that varies based on your hardware. Oh, it's not. We're not properly checking the edges, it looks like. We can see what's going on there. Yeah, see, it's bleeding over. We're doing something wrong there. Let's see what we're doing wrong. Let's check our get neighbor indexes. Are these hooked in? Yep. Let's go through here. Neighbor pass grid edge. Let's see if this is hooked up right. Far left. I think this is wrong here. Yep. Let's see if that fixes it. Can we get this to, oh, there we go, maybe. We just wanted to get to one of the edges. It's harder than it may seem. Ah, there we go. That should move. I keep guessing wrong on how to move these things around. There we go. That should get to an edge. Okay, it doesn't bleed through. Yep. that we were just doing it in the wrong order. So currently, functionally speaking, it basically treats all the edge cells as dead that can never be changed. So that's how it's kind of acting. You could have it bleed over. That might be a cool effect even. But you'd have to do the math a little bit differently on how it calculates grid edges, because you'd want it to bleed over both left and right. Which I did a asteroids game that kind of did that. So it's not too hard. Maybe I'll do that as a tutorial eventually, but sorry, it's just so cool to watch. Okay, we're getting distracted. So this works. This works. The next thing we're going to make, these were from the previous, is the UI. So the actual, maybe we want to create the last of these functions here. We only really have 2 more. Yeah, let's do that in the life grid here. So we got this updates life. This creates center. You don't actually need this to work, but I like it spawning with it doing at least something. And that 3x3 grid is kind of cool to like kind of get this started off. This one is, this is creating the actual grid. And then this is user clicked cell. There's 2 more kind of sequences we need here, or events. This is going to be called reset all cells. And it's not too complicated relative to the stuff we have been doing. We're just going to clear this. And then also clear this. And then we're going to do a for root loop for each. And we're just going to kill them, which is set cell to be dead, just like that. This is just reset all cells, which we'll call this in our UI. And then the last thing we need to do here, we need another custom function called set time delay. And you might think like, well, the update delay is right here. Like, can't we just set it to whatever we want? And yes, but we need to turn this timer off and turn it back on, basically. Because if we just set this, it doesn't actually care, because it only registered that value when we first initialized this event. So we basically just need to reinitialize it. Maybe there's a better way to do this, but I'm going to do clear. We're just going to clear and invalidate. And then we're just going to, we'll do a little sanity check, which is just, hey, is this more than 0? Since we don't want to start the thing if it's more than 0. But if it is, then we can just call the initial function, which is start cell update, just like that. So it's like, hey, if it's more than 0, then go ahead and update the timer. Change the time delay. There we go. This is, I think, all the functions we need within life. The next things we're going to make this user, and what would we call this? Life widget. Let's open it. We can close the material. Heck, we can close this cell even. Grid. Character we still need. We can close all these. Okay. Spawn the grid. This is just quit game. This is create widget. Which, do we have it referenced? We do. So we can just slot it in. There we go. And we want a reference to this. Widget ref. And then we're going to add to viewport. And we need to create a function now. Okay. Within the widget. Which, okay. We're going to have a few different controls. I'm going to show you on the other project here. So we have a pause button. We have a slider for what we want the time delay, which will unpause whenever we let go of it. And then we have a reset, which also pauses the game so we can click on things. Did I break something? No. I'm just lagging. Okay, the other project crashed. Great sign. But while that is doing its thing, we're going to make the widget. And I underestimated the time on this project. It's going to be close to a 2-hour video. We'll try to restore it. I doubt it. We'll be able to. Okay. All right, let's go ahead and create this function real quick, just so we initial set initial setup. There we go. We could use the onConstruct, but we actually want a variable here, which we're going to call the life grid. We want to be able to reference it, which is going to be type life grid. I'll drag that in there, and just like that. So now that we've done this and compiled it, we should be able to call the initial setup here. Just like that. So this is set up the UI. So we're actually done with the player as well. Sorry. Time is short. Okay, the things we want to do in the initial, we're gonna make a little function here. Round to tenths. I think there's a function in Unreal to do this, but I'm having trouble finding it. So we're just going to make one. And all we're going to do is we're going to multiply by 10. We're going to truncate. And then we're going to divide. Oh, we'll divide this. Not actually, but we want to truncate it back and then divide by 10. That's it. Because we only want, and we'll just call this input float. Sorry, I'm leaning back a bit. Okay, input float, and then the output will just be a rounded float. Just like that. And we can make this a pure function. There we go. Okay, round 2/10. And we're just going to get the update delay. And use this. Okay. So this is going to be part of the initial setup. Let's actually lay out the sections itself. We're going to have a slider. We are going to have some 2 buttons. We are going to have some text. And we are going to have some text in the buttons. Okay. Can we size the content? There we go. All of these, I think we want to anchor to the bottom center. These two, this one we want centered. We can size it to content. And make 0.5 like that. Okay, it's nice in the center. And then these 2 buttons, we can put maybe 400. No, that's too much, or not enough. Be like minus 200, minus 100. It should be fine. And we'll do 0.5 for this as well, so that they're centered. Okay, this will be, we're gonna just do update delay in seconds, like that. And we'll go ahead and put an outline on this, just by 1, just so you can see it a bit better. Let's bring this down a little bit, like that. Bring this down a bit as well, maybe 50, minus 50, 70, 80. And then we'll make it, keep that the same, make it wider. Make it a bit taller, I guess. Make it like 60, 430 works. The value here, the step size, let's increase to 0.1, since remember we're rounding to tenths. And then I'm also going to, let's see, I want to make the bar a bit bigger, which is under style, and then this. So see, it's 8 by 14 on all these, so we're just going to change this to like 36, just to make it a bit bigger. or 64? I actually like 64. Being a bit bigger makes it like this, like 16. So it's like on the other one, it's a bit finicky to grab. And then we can label these, which will be life speed slider. It's a variable. This is going to be the reset button. Actually, this is going to be the reset button. This is going to be the pause button. This is the reset button. And this is the speed text. And we want to set this to be a variable. These two will add a strike as well in the font. There we go, just so we can read it. And we can label these appropriately. Pause. Pause. And reset. Okay. There's our UI. We should be able to see this. There we go. Doesn't do anything. We can move it, but nothing happens. We can click these, but nothing's happening, which is fine. Okay. So now we're going to create the code for our UI. We're going to do set value of the speed slider. And we'll just put that into there. So you know, so when you start, it actually sets to what it's supposed to be. We're going to create our last little function here. And we are going to, this one will be set slider text, since we're going to use it a few different times. And all we're going to do here is go and grab the text, grab it in like that. We'll just label this to be text, and then we'll just set text, this one. And then we're going to need an append. We're going to plug this in here since we want to convert from a string to the text. And then we are going to add a float. In float. This will go, not there actually, it's going to go in the middle. Since this we'll click space and then second, since remember that's how we have it here. And then we're just going to copy everything before these two dashes like this. And make sure to have a space there. So that way, every time we want to set the text, we don't need to put all the stuff around it as well. We can just grab this guy like this, set the text here, and grab the float. So now you notice when we start, it actually says the rate in which it's updating. It doesn't do anything yet, but we've created at least all the functions. Start up. Okay, so then let's work on the pause button first. So since the pause button will, a few of the things we make in that will get referenced by other stuff. So we are going to do two things. We're going to do one on click. And then we're going to need a variable here, which is just paused. This is just going to be a Boolean. And then the other thing is we're going to stored update delay, which is going to be a float. And so do different things on the pause button depending on if we're paused already, right? So if we are paused, we want to set and then we click pause. We want to set the slider value. To whatever this stored update delay is. Do we set this here? No, we don't. And then with our grid, we want to set the time delay. Remember, this is the function we made here. That's why we made it, so we can just reference it now. And we're going to get that stored time in. And then we're going to set the slider text, which is this function we made here. Speed text. Like that. And then we are going to set things to be unpaused since we're no longer paused. And then lastly, this pause text, we want to set as a variable. Let's label it. Pause text, reset text. And then we can just set this text. And we are going to just label it to pause. Okay, and then the reason I just did this like this is since we can actually copy almost all of this here without the grid, because if we pause it, we're going to do all that, but we're going to reset it to 0, right? And except we're going to set this to be paused, and then this is going to be called unpause, is what we're going to set it to. Right. Okay. Very nice. The one thing we're going to do before we actually jump to that is we are going to set this to, we are going to grab the grid and we're going to get the update, get update delay. So you see what it's kind of doing. It's like when we pause it, it's like, hey, if you click pause and it's not paused, go ahead and grab whatever the update delay is and just like remember what it is. So that way when we unpause, we can just jump right to that instead of having to pick a random value. And then two things we're going to do, we're just going to make a custom event and we're just going to click pause live. This is so we're going to reference this in just a moment. And then same here on this second one, the set time delay, we're going to do another custom event and we're going to unpause, pause live, which we'll both get. Okay, so this is the pause button. Okay, the reason we made those two is on the reset button. So click the reset button. When you click the reset button, it's going to do two things. It's going to reset all the cells, which is referenced through the grid life, and then we're just going to also pause life since we want it to pause whenever we click reset. That's the reset button. And the last one we make, which is the slider, we're actually going to reference two different things here. We are going to, one is going to be on capture end, mouse capture end, which is when you let go with the mouse basically. And then the last thing is on value change. And we're going to kind of do two different things with this. So the on slider change, all we want to do is set the slider text. That's literally it. And we can round to tenths like that. Make sure to pop your, wait. Oh, right. Speed text. There we go. So it's like, hey, as you move the slider, go ahead and change that value so you know what you're moving it to. But it's not actually going to do anything until you let go. So I will, okay, we're going to grab this, and then we're going to get the value here of whatever the value of the slider is. We're going to round to tenths, and then we are going to put this in the stored update delay. And we are going to unpause live. Like that. So basically what this is saying is, hey, as you move the slider, remember what value it is when you let go of it, and then unpause things. Obviously you can change the slider even while it's not paused, but this still, if you notice where we clicked unpause live, we are going to be setting the time delay, setting the stored, and we are going to set this to be click pause. So it's going to unpause. So that isn't going to be a problem at all. So let's test it out. So you click, see it pause, you notice our slider moved and the text changed. We can move this around and you notice our text is changing, but nothing is happening. But as soon as we let go, now it's updating at that new rate. Let's make it a bit quicker. So you notice it's updating quite quick. We can reset. Notice when we click reset, it pauses and moves the slider, changes the text, and changes the button. So the reason we do that is so we can, typically when you reset, it's usually because you want to draw something. And then you can click unpause and it remembers the speed. And there you go. This is everything. So we have made Conway's game to life with a few controls. Very long video, but I thought it was quite cool. I did it over the course of a few days, and I hadn't seen anyone do this in Blueprints, and I wanted to put it out there on how to get it done because it's a really cool game, and kind of remaking it yourself, I think really helps you kind of learn the intricacies of how it works, which I find super fun. We're pausing it. I'm gonna see if I can recreate. There's like I think that's a glider. Yeah, there's a few different like famous symbols. Let's see here. So these are a few like ones that don't move. Here's a few pulsing ones. Let's do this one here. So it's just like a grid of 4 and 4. Oh, let's do it here. Yeah, flash is very cool. Let's do this one. So it's like 3 and then 3 with 2 overlapping like that. That's fun. And then let's make a glider going in this direction. It's kind of like that. So cool. All right, well, I'll catch y'all later. Have a good one.